In 2023, the world watched quietly as India did something truly extraordinary. Not with billion-dollar rockets or decades of global dominance, but with a mission that cost less than a Hollywood blockbuster. India's space agency, ISRO, successfully landed Chandrayaan-3 on the moon's south pole, a treacherous region where even richer nations had failed. The whole world was left wondering one thing: how? How does ISRO pull off these incredible space missions at a tiny fraction of the cost of NASA, the European Space Agency, or China? And more importantly, what trade-offs do they make to stay this affordable? We need to watch that changing. Chandrayaan. Let's start with the numbers, because they are absolutely mind-blowing. Chandrayaan-3's total mission cost was around 615 crore rupees, which translates to about 75 million US dollars. Now, let's compare that to another famous mission, NASA's Perseverance Mars rover, that cost about $2.7 billion. No, that is not a typo. The Indian mission to the moon cost less than 3% of the American mission to Mars, of course. These missions aren't identical. A Mars rover is far more complex and travels much farther. But the cost gap is so vast, so staggeringly huge, that it can't just be explained by the difference in scale. The real answer lies in a fundamental difference in philosophy. While many space agencies start by asking, how much science can we possibly do? ISRO's first question is, what is the absolute minimum we need to succeed? This frugal, mission-first mindset shapes every single decision they make. Chandrayaan-3 had one-on-one primary goal to prove that India could safely land a craft on the moon and operate a rover on its surface. That's it. There were no grand secondary experiments planned for orbit. No massive multi-instrument science packages. No ambitious multi-year operational timelines. This singular focus was the key. In fact, Chandrayaan-3 didn't even carry its own orbiter. ISRO made the brilliant decision to reuse the orbiter from its previous mission. Chandrayaan-2 moon. This saved them the immense cost of designing, building, and launching entirely new satellite. By strictly limiting the mission's objectives, ISRO drastically reduced the spacecraft's weight, its complexity, the amount of testing required, and of course, the cost. The trade-off here is clear. ISRO's missions often generate less scientific data compared to the sprawling, multipurpose missions from NASA or the ESA. But what they gain is invaluable hands-on experience and a step-by-step path to building more complex missions in the future. They prioritize maximum learning for every rupee spent, not maximum science at any cost. Another cornerstone of ISRO's cost-saving strategy is its relentless focus on reuse over reinvention. Chandrayaan-3 didn't introduce flashy, unproven systems. Instead, it relied on battle-tested technology. It was launched on the LVM-3, ISRO's most powerful and reliable rocket. It used upgraded, but fundamentally familiar, propulsion systems. It leveraged existing ground infrastructure and tracking stations that have supported missions for years. This philosophy was most evident after the heartbreaking failure of Chandrayaan-2's landing attempt. ISRO didn't go back to the drawing board and redesign the entire spacecraft. That would have been slow and expensive. Instead, their engineers meticulously analyzed what went wrong and fixed only those specific things. They strengthened the lander's legs, improved the landing sensors, refined the software logic, and fine-tuned the descent control algorithms. They didn't rebuild what already worked. The trade-off of this approach is a slower adoption of cutting-edge, next-generation technology. ISRO isn't always the first to fly the newest, shiniest hardware. But what they lose in novelty, they gain in reliability per rupee spent. At ISRO, the belief is that innovation should be incremental and steady, not reckless and rushed. This approach is all part of a deep-rooted culture of what's known as frugal engineering. This doesn't mean building cheap, low-quality things. It means achieving maximum performance with minimum resources. It's an art form. For example, ISRO prioritizes developing components indigenously in-house instead of buying expensive parts from international suppliers. They often opt for simple, reliable mechanical solutions instead of complex and failure-prone automated systems. They also carefully calculate their safety margins. Instead of over-engineering every component to be 10 times stronger than it needs to be, which adds weight and cost, they engineer it to be just strong enough, with a sensible buffer. After the Chandrayaan-2 failure, ISRO did add critical redundancies, but only where they were absolutely necessary to prevent the same failure from happening again. The trade-off is that their spacecraft may have fewer backup systems compared to a typical NASA probe. This means that if something goes wrong, the consequences can be more severe because there are fewer second chances. But when it works as it did with Chandrayaan-3, it works beautifully and at an unbeatable price point. Of course, we can't talk about cost without talking about people. Another major reason ISRO is so affordable is its workforce structure. ISRO's scientists and engineers are salaried government employees. This creates stable, long-term teams that stay together for decades, accumulating invaluable experience and institutional memory. Furthermore, ISRO does most of its work in-house, with very limited reliance on a complex web of billion-dollar private contractors. Compare this to NASA, which heavily outsources its work to companies like Lockheed Martin, Boeing, or SpaceX. While this drives innovation in the private sector, it also adds multiple layers of management, administrative overhead, and profit margins that drive up costs. By keeping things internal, ISRO benefits from faster coordination, lower administrative expenses, and a shared sense of national purpose. The trade-off? Salaries at ISRO are significantly lower than what a top aerospace engineer could earn in the private sector globally. This creates a risk of talent moving to private companies, but for now, the passion and prestige of working for the National Space Program keep many of India's brightest minds right at home. Finally, let's talk about testing. ISRO tests its hardware rigorously, but also strategically. It doesn't have the budget to test for every conceivable failure scenario under the sun. For Chandrayaan-3, they focused their testing budget like a laser on the things that went wrong the first time. They ran thousands of landing simulations on computers. They physically tested the lander's sensors in various failure scenarios, even dropping a test model from a helicopter to see how it would respond. They poured resources into ensuring the software was robust and reliable. What ISRO does not do is build parallel backup missions, like NASA did in the early days of its Mars program. They don't build multiple full-scale test landers for practice runs. They don't conduct redundant, full-scale rehearsals of every mission phase. In essence, NASA often designs for near-zero probability of failure, which is astronomically expensive. ISRO designs for a high probability of success, which is much more economical. The trade-off is a slightly higher, but still acceptable, level of mission risk. But the reward is a dramatically lower cost that makes space accessible. So, how does ISRO reach the moon for less than a Hollywood movie? It's not by cutting corners. It's by choosing its corners very, very carefully. The success of Chandrayaan proves that a focused mission can beat an excessive one. It shows that deep experience can be more valuable than constant novelty. And it proves that having clear, simple goals is more powerful than having unbridled ambition without a clear direction. ISRO isn't trying to win the space race by outspending its rivals. It's why I think him. And in a future where access to space becomes more about practical utility than national prestige, that might just be the most powerful and sustainable strategy of all. Thanks for watching. And if you enjoyed this look into frugal innovation, be sure to follow for more.